Welcome back and let's discuss the muscular system. The muscular system. And you know that the muscular system, we're always going to be studying the muscular system from an anatomy, which means structure, and physiology, which means function. So we're going to be investigating the muscular system from two perspectives, from anatomy and physiology perspective. But before we go into the muscular system, let us refresh our memory about the human tissues. So there's muscular tissue also. So we have the human tissues. Human tissues, we already discussed how many of them. What was the very first, number one, human tissue that we went over in this class? Human tissues. What was the very first human tissue that we discussed in this course? Who remembers? So the epidermis is where we find that tissue, but the epidermis is not a form of a tissue. I'm sorry? Excellent. So the epithelial tissue, and we do find that in the epidermis and the dermis. So this is the, number one is the epithelial tissue. And we said epithelial tissue is always classified based on two criteria. Criteria number one is the BM. And what does BM stand for? Basement membrane. And also on the cell shape. How does the cell look like? And we said as far as the basement membrane is concerned, we know that the basement membrane can come in one of two different structures. So let's say this is our basement membrane down here. That's the basement membrane. The basement membrane. And you know that the basement membrane, you have two different structural arrangements. That's number one, and that is number two. Number one and number two. Number one is known as simple. Simple because it is only one layer. So you have one layer of cells attached to the basement membrane. You see? One layer of cells attached to the basement membrane. What is the other arrangement known as? Excellent. So this is stratified. Stratified means what? Multiple layers. Two or more. Two layers or more. A minimum of two or more. So multiple layers, like two or more. Okay. Is that all? Is that all the classification we need to know for the epithelial tissue? So we have the basement membrane and we have the cell shape. Cell shape, there are how many cell shapes that the epithelial tissue can exist in? 3. 1, 2, and 3. What's the first type of cell shape in epithelial tissue? That's called the squamous. And squamous means flat, scaly, egg sunny side up, like this. Squamous. There is also cuboidal, which means that a cell has a length and a width, and both are equal. The length equals the width. And lastly, we have a columnar. Columnar tissue. And here you see that the length is way more than the width. Right? So now if I want to classify my epithelial tissue, I mix and match. Simple squamous, simple cuboidal, and simple columnar, or stratified squamous, stratified cuboidal, and stratified columnar. Clear? Okay. Number 2, we talked about what's the second type of tissue? It's known as the connective tissue. And there are so many different types of connective tissues. There's bone tissue is a connective tissue. Blood tissue is a connective tissue. And there is hyaline cartilage. There is also fibrocartilage. What else? There is also loose connective tissue. There's also dense connective tissue. And there's also adipose tissue, fat, adipose, lipid, adipose, lipid, and fat tissue. Is that clear? Clear? And we have the tissue number 3, and that is the nerve tissue. And lastly, we have the muscular. So we have nerve tissue, and that is only one form, and there is muscular tissue, and muscular tissue exists in 3 forms. Muscular tissue exists in 3 forms. 1, 2, and 3. There are 3 forms of muscular tissue. 3 forms of muscular tissue. The first form of muscular tissue is known as smooth muscle tissue. Then there is skeletal muscle tissue, and then there is cardiac muscle tissue. Is that clear? Okay, those are 3 types of tissues that we're going to talk about. For your lab practical, you only need to know about the skeletal muscle. So a smooth muscle is the type of muscle we find in the blood vessels, like your arteries, and your veins. Skeletal muscle is a type of muscle that you'll find on the skeleton. That's why they call it skeletal muscle. It is found on the skeleton. That is found on the skeleton. Found on the skeleton. True or false? And lastly, you have the cardiac muscle. Where do we find cardiac muscle? The cardiac muscle is found in the heart. Okay, so now we're going to be talking about those three different types of muscles. Smooth muscle that is found in the blood vessels, and skeletal muscle that is found in the bones, and cardiac muscle that is found in the heart. So let's go into our muscular system. So remember, in the end of the day, whether you are smooth muscle, whether you are skeletal muscle, if you are smooth muscle, if you are skeletal muscle, if you are cardiac muscle, in the end of the day, you're what? In the end of the day, you are a muscle. You are a muscle. Doesn't matter if you are a skeletal muscle, or you are a smooth muscle, or a cardiac muscle, you are a muscle. So there must be universal signs that are there between all of the different types of muscle. That's what makes them muscle. You know, monkeys come in different types of species. There's like the orangutan and the chimpanzee but at the end of the day, they're all monkeys, right? You have the dogs. They come in different forms: pit bull and Shih Tzu and Chihuahua and what else? What else? Rottweiler. That's the one you have at home. This is the nice one, the Rottweiler. Isn't that the friendly one? So they're all dogs. They're all dogs, but they have different names. But they gotta be dogs. So same thing. Muscles. They can be smooth muscle, skeletal muscle, cardiac muscle. They're all muscles. But there's slight difference. So under the microscope, does it make sense for you to assume that all muscles, whether they are smooth muscle, whether they are cardiac muscle or skeletal muscle, if they all are muscles, are they looking the same? Do they look the same under the microscope? Do they all look the same? Are the three identical under the microscope? No, because they have different structure and they have different function. You saw there, the smooth muscle is in the blood vessels. The skeletal muscle is on the skeleton. That's why they call it skeletal muscle, like your bicep, your tricep. And you have your heart muscle, that's the one that pumps the blood. So their jobs are not the same. Are their jobs the same? No, their jobs are not the same. So will their structure be the same? Absolutely not. So let's begin with the structure of the muscular system. Muscles will always be in very concrete units. So in muscular tissue is a tissue that is, in its physiology, your muscular tissue is a contractile tissue. That means your muscle, no matter which muscle we're looking at, is it a skeletal muscle? Is it a smooth muscle? Is it a cardiac muscle? If it's a muscle, it's gotta contract. What is contraction? Contraction means becoming shorter, becoming shorter. after electric stimulation. Clear? Are we clear? And the muscles have to be excitable, meaning that they mediate the passage of electric voltage change. So your muscular system is important for movement. So someone who is paralyzed from the waist down, are they unable to walk because something is wrong with the bone or something is wrong with the muscle? Something's wrong with the muscle. So yes, your bones are important for movement. But who moves the bone? It is the muscle. The muscle itself. Who moves the muscle? The nerve. So the nerve stimulates the muscle stimulates the bone. So the three of them, one comes after the other. Have you seen those big caterpillar? So the person inside the really big cranes and caterpillars, they press a button. So the button sends an electric stimulation that makes the wires cause these really huge structures to contract and be able to grab things and move them. Your body's like that. The nerves stimulate the muscle stimulate the bone contracts and moves. Flexion, extension of the joints, that is because of the nerve. So somebody who is paralyzed from waist down, you see that their thighs are really thin. Their thighs are so thin. Why? Because the nerve is paralyzed. So the nerve is not stimulating the muscle is not stimulating the bone. It's kind of if you don't use it, you lose it. Because the muscle is not being stimulated, it atrophies. So the same way when you stimulate your bone, when you lift weights, the Wolff law of the bone says that if you stimulate your bone tissue, it gets denser and stronger, especially for women. Women, they have to go to the gym because when menopause comes, then women suffer from osteoporosis. So the bone tissue becomes really weak. But the women who run and they go to the gym and they exercise, when menopause comes, it's a piece of cake for them. Really nothing. So the bone still is very strong. Is that clear? So the more you stimulate the bone, stronger it gets. The more you stimulate the muscle, the more you stimulate the muscle, the muscle is going to become stronger. Is that clear? So, number 2, the movement. And we have also another function. What's another important function for your muscle besides movement? Have you ever seen somebody who is starved to death and their muscles shrink? Why do they shrink? Or somebody who's going cancer chemotherapy, the muscles shrink. Or the opposite, someone who's really obese and they eat a lot of sugar and cake and pancakes and they are so obese, and when they go running, what happens? All of the sugar in the blood goes in the muscle. So the muscle gets really big. So why is that? Interesting. Let's say I eat so much sugar, so much pancake and syrup and ice cream, or suffer from the obesity. Then I go to the gym, I run, then I go measure the sugar in my blood. It went down. Where did it go? Where did sugar go? In the urine? The sugar went in the urine? The sugar went in the feces? Where did the sugar go? Again, I go to the doctor. The doctor says you eat a lot of sugar, you're suffering from obesity, and there's so much sugar in your blood, you're gonna have diabetes. Go to the gym. So I go to the gym, I'm running in the gym, and then after a while, I measure my blood sugar, it dropped. What happened? And my biceps got really big. Why? Because the sugar went from the blood to the muscle. So the muscle is important for storage. Storage of sugar. Storage of sugar. The muscle is important for storage of the sugar. True or false? False. True or false? True. So we store the sugar in the muscle. That's why in starvation, you see the muscle tissue breaking down. Clear? Now, so the physiology of the muscular system is that it's all about contraction and all about excitation. And it's important for movement. The muscle tissue is important for movement and storage of the sugar, the carbohydrates, especially glycogen. Carbohydrates. Especially glycogen. Clear? Any questions? Are there any questions? Any questions? No questions. Okay, lastly, I want to talk about the relationship between nerve muscle relationship. Nerve muscle relationship. That is known as the neuromuscular junction. That is known as the neuromuscular junction. Yeah, you're not in here. It's only me. The only one who want to be famous is me. I'm not going to allow anybody from here to share their fame with me. Did you guys hear the latest news that I came up with? I'm going to go put on all my illustrations a GoFundMe, not for you, not you, but for the world. If you like my videos, if you learned, pay here. I'm going to go viral and the whole world is going to pay me. Raise your hand if you think so. No? What? I'm not that good? Oh, I think I am. But some students told me don't do that. Do Patreon, do PayPal, Venmo. But we're working on it. We're working on it. If you don't see me here anymore, guess who became a millionaire? Yes. Anyways, so let's talk about the nerve-muscle relationship, also known as the neuro-NMJ. NMJ. Neuromuscular junction. Neuromuscular junction. Heard about that? Raise your hand. You guys went over that in lecture? What is exam? When is exam? Monday. Did you go over the neuromuscular junction? Yes. Okay. So what happens in neuromuscular junction? So let's talk about the names. N, M, J. N for neuro, M for muscular, J for junction. But what happens at the neuromuscular junction? The nerve is stimulating the muscle. The nerve is the computer telling the muscle to contract or relax. But how does it do that, though? How does the nerve tell the muscle to contract? Does it talk to it? It does. Yeah. Yes.
Is there a brain
Yes, so your brain on the spinal cord stimulate the muscle. Your brain stimulate your cheeks, your facial muscles, your muscles of mastication, chewing. That comes from the brain. You're right. Your spinal cord stimulate your legs because it's closer down there. It's like a state government and a federal government. The brain is the federal government. The spinal cord is the state government. But my question is, how does it do it? How does the brain tell the cheeks to contract? Oh, you're blushing. Oh, you're embarrassed. Oh, you're angry. How does it tell it that? Oh my God, I'm blushing. I love this person. How does it know that? Because how does it talk? Yeah, they actually do. They talk to each other. They talk. But do you only talk with sound? With sound? Is only talk with people only talk with sound? Yeah, you get. I heard a word that's real interesting. Somebody shouted it out. Brian. Dendrites. Good. So the dendrites are part of who? The muscle or the nerve? The nerve. So the dendrites talk to the muscle. How? With sound? You know people don't always talk with sound. You know there's sign language. That's talking too. That's talking. If you learn sign language, you're going to have more friends. You're going to be able to talk with more people. But not with voice. Not with voice.
With little signals?
Yeah, very good. What signals? You see, you guys keep saying words that are like not complete. Okay, signals. What signals? Sound signals? Sign like. Yeah, very good. We're getting there. It's like, you know, when you used to want to start up the car, it's not really starting, but we're getting there. Something is happening with the dendrites, signals, synapse. Neurotransmitter. Excellent. You're very good. Neurotransmitter. So Ryan said we have a dendrite. This is the whole axon. The axon is so long, but this is the dendrite. The dendrite has bubbles, balloons. Balloons full of what? Balloons full of what? She said it. Full of?
Vesicles.
Yeah, those are vesicles. Good. Balloons, vesicles. Vesicles full of what? Acetylcholine. ACH. ACH. So all the bubbles are found on ACH. And who's across street? Who's across street? Here. Who is that? What does this look like? Good. So this is the muscle. And this is the nerve. And this gap here, what do we call this gap? Synapse. This acetylcholine tells the muscle to contract. But how is it? You know it's locked in a vesicle. It's not coming out. Who makes it come out? You know it's not just going to walk out. Somebody got to make it go out. Who makes it go out? I'm hearing things, but I cannot hear them. Say them. Yes?
I don't know if it's right. The motor end plate.
This is the motor end plate. Because this is the... Remember I told you that we have an effector. So the muscle, the effector is always a muscle or a gland, right? So this is the motor end plate. That's the plate of the nerve, and that's the motor effector. So who makes that acetylcholine come out? Calcium. That's the second step. So the second step is calcium coming in. It's called the influx. 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 So when calcium comes in, who comes out? ACH is going to butt off. ACH is going to come out. ACH is going to be released in the synapse because calcium came in. And who makes calcium come in? Now you guys are saying nonsense. Mitochondria. Now that does not make any sense. Yeah, very good. You're very good. Excellent. So an action potential. So an electrical action potential, electrical action potential. That's the number one. When the electrical action potential comes here, the sodium influx. When the sodium influx, acetylcholine comes out, called efflux. 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 Acetylcholine comes out. When acetylcholine comes out, there are what on the muscle? What are out there in the muscle? What are those? What are those? What are those?
Oh,
The
The meiosis.
meiosis?
Meiosis.
the binding.
Yeah, the binding site for acetylcholine, called acetylcholine receptors. So the acetylcholine receptors are going to bind to the ACH receptors. You know, we don't just have a neurotransmitter. The neurotransmitter got to bind to the receptor. So now acetylcholine binds receptor, acetylcholine binds the receptor, acetylcholine binds the receptor, acetylcholine binds the receptor. Is that clear? When acetylcholine binds the receptor, what happens? Now we finished with the nerve, we finished with the synapse, now we're inside the muscle now. The acetylcholine receptor is itself a channel that opens. Is itself a channel that opens. This is a channel of the acetylcholine receptor. What does the channel of the acetylcholine receptor do? It causes something to come in, blue influx. There is blue influx and there is red. What's the opposite of influx? What's the opposite of influx? Efflux. So when the acetylcholine binds the acetylcholine receptor, the channel opens. Sodium influx. Sodium goes in. Sodium comes in. Influx. And who comes out? Efflux. Potassium goes out. Now, how does this change the world now in the muscle? When the sodium comes in and the potassium goes out, what happens to the muscle? It begins it's like the dominoes effect. Now you tipped over one domino. What's going to happen? Now there are nearby voltage gated channels. Voltage gated channels. What are voltage gated channels? Those are channels. You know, you have doors that open with the fingerprint, doors that open with the key, doors that, it depends, they open different ways. Doors that open with laser. Those channels are voltage gated channels. What is voltage gated channel? Is a channel that opens when the voltage changes. This door, it opens when the key is in the knob, not when you put your fingerprint. Let me go put my fingerprint in this door. Is it going to open? It's not how it works. Those channels will only open when the membrane potential around them, changes. Did it change? Yes. Why did it change? Exactly, because acetylcholine opened, blue sodium came in, red potassium came out, the membrane changed. Now they open too. When they open, now they will open, but each one has his own channel now. It's not mixed. In the ACH receptor, the channel has mixed. Both of them, sodium goes inside and sodium goes inside, potassium goes outside. But for those channels, there is one channel for sodium to come in, one channel for sodium to come in, and one channel for potassium to go out. And those channels propagate a membrane potential. There is like millions of them. When this happens now, this is all happening inside the muscle. That causes the sarcoplasmic reticulum to release calcium. To release calcium. To release calcium. Now, where is calcium released now? In the muscle. You see, calcium was released first in the nerve. Then calcium is released in the muscle. See how important calcium is for the contraction? So now, this calcium in the nerve, it helped the acetylcholine to be released in the synapse. What about this calcium in the muscle? What does it do? How? Now, we're going to introduce the last thing, which is the Golgi heads. There is a protein known as, it has like two Golgi heads, two intertwined Golgi heads. You see the Golgi head? Anybody played golf? Anybody played golf? Anybody played golf? Good for doing that. The most boring, the most disgusting sport. I don't even know how people play it. Where's the ball? Is it over there? Let me go kick it. I don't like it. It's good. My faith in humanity has been restored. Okay, so there's a Golgi head that is intertwined on another Golgi head. So that's Golgi head number 2. You see the two Golgi heads intertwined? Okay. This is called what? Yeah, you're almost there. But what do we call this structure here? The double Golgi head. Myosin. So myosin has two Golgi heads. 1, 2 Golgi heads. That's the first protein you need to know. Myosin. And there is another protein that looks like balls that have pockets in them. Balls that are hollow from inside. Balls that are empty and hollow from inside. Balls that are empty and hollow from inside. What do we call this protein that looks like a ball from outside, but from inside is hollow? What do we call that? Actin. This is actin. So now, you said something really nice, the sliding filament theory. Sliding filament theory means that the myosin heads will enter in the holes and the pockets of actin and contract. This is called the sliding movement or the cocking stiffness movement. So the entry of the myosin Golgi heads in the pockets of the actin and the contraction of the sliding stiffness, the cocking movement happens when myosin was inside here. Well, don't be in a hurry, because are the pockets empty all the time? Are the pockets empty? Or the pockets just empty right there? Are they? Who's covering the pockets? Who's covering these pockets like a net? There is a net. Oops. There is a net here. What's the name of this net? This net here that is locking and closing the active side. This orange net. What do we call this net? What do we call that? No. Myofilament is like multiple muscles. No. What do you call this net that is covering the pocket socket, protecting them from the Golgi heads from going inside? Well, count them. actin, myosin, tropomyosin.
Or tropomyosin.
So this orange one is tropomyosin. So tropomyosin job is to cover the holes, the active pockets, and disallow, not allow, and prevent and not allow the myosin to go inside the actin pocket. Is that clear? Well, there is something on top of the tropomyosin that looks like this. Something on top of the protomyosin in green. Something in green on top of the. What is this in green here, and what is its job? What is its name? First and foremost, what is the name of it? What is the name? Troponin. That's troponin. So troponin is on top of the tropomyosin, and tropomyosin is on top of the troponin is on top of the tropomyosin, and tropomyosin is on top of who? The active sites. So, I said my question earlier. Now we did all of this. Acetylcholine coming from the nerve, binding acetylcholine receptor, stimulating the opening of acetylcholine receptor channels, sodium influx, potassium efflux, then the dominoes effect, positive feedback, a lot of sodium and potassium channels opening, causing membrane voltage change, and that leads the sarcoplasmic reticulum to release who? Calcium. So calcium binds troponin. Calcium binds troponin. When calcium binds troponin, what happens? When calcium binds troponin, what happens? The tropomyosin pulls down who? Tropomyosin pulls down. So troponin, when calcium binds troponin, troponin pulls down tropomyosin. When tropomyosin is pulled out, the active sites are now exposed, and then the myosin golf heads will go inside the pockets and perform the stiffness sliding filament cocking movement. Is that clear? And then this contraction is going to stimulate the bone to contract, and that's going to cause the movement. Is that clear? Questions? Questions. Alrighty. So, if there's no question,